This is a presentation for cognitive mission for computer architecture, and I'm going to speak about the cognitive mission to machine communication. How using the protocol, how we are going to use the protocol for cognitive mission to mission. So let's see. First, today's the world is moving towards the machine-to-machine communication. We all know that everywhere devices are connected. So, to facilitate the machine-to-machine communication, we are inventing many technologies that will support the machine-to-machine communications. So, likewise, we have introduced a cognitive machine-to-machine communication. Cognitive is like it's like which transceiver detects the channel. Cognitive is like the channel will not be waste. So the channel which is not in use will be used for another channel, for another transceiver. So we need not want to have as many as possible. So with the limited number of channels, we can assign the user's work. So that's why the machine-to-machine, the cognitive has been wireless communication has came into existence. So we are combining the cognitive channel into machine-to-machine. So likewise we should include the machine-to-machine such a way it will be useful for the user, and time will not be waste or anything will not be waste. So there are many protocols that is going to explain, and we have done so several literature survey in what ways they are implementing the cognitive radio machine-to-machine communications. So in machine-to-machine applications, we include securities and public surveillance. We are cognitive machine-to-machine communication will be in small grids, vehicular telemetry, healthcare, manufacturing, and remote maintenance. We are using the cognitive machine-to-machine communications in anywhere in this field. And then the methods, the survey which I made is based on the three. So we are using these three protocols for the cognitive machine. So let's see how they are using these three protocols for the cognitive machine-to-machine. So this is IEEE 802.15.4M protocol that is used in the cognitive machine-to-machine communication. How it's used? Let's see. We having a full functional device and reduced functional device, and then full functional is like a node. It is like a head which connects the reduced function device. So the n number of reduced function device will be connected to one function, one full function. Likewise, the full function devices every full function devices will be connected to a PAN coordinator. So let's take this one area is one PAN and this is another PAN. So the full function coordinator devices will be connected to the PAN coordinator. So in this area, this is the coordinator. So this will act as a master slave, and it uses to communicate and uses to check the usability of the channel. And then each PAN has a call. So it is like a clustered tree. Device to device connectivity is also possible. So likewise, it is directly connected to one another. The second method which I surveyed is PRAM based cognitive MAC. PRMA is like a packet reservation multiple. It is developed for this M2M networks, which uses a time division multiple access, and this is having empty CDs, that is disk devices, and then customer devices, and then gateway. All the customer devices are connected to the gateway, and the gateway will be act as a master slave over the communication, and then the M2M server will be connected to the master gateway, MTCG gateway. And like this protocol packet reservation, so this will receive the packet, and it will tell where to forward the packet, the packet belongs to whom. It will detect and it will check. So the rest other device domain will be compactably used. And this is CRB MAC protocol. This is also a receiver based. It like a spectrum uses, and it first sends the spectrum. So it first sends the spectrum. So this is the transmission range. So now the S node wants to transmit, and it is first sends the spectrum. So if it sends the spectrum, then it will detect the C, A and B. This S will detect, and then if it will check whether if it is busy or not. If that ABC is busy, then the S node will go to sleep state. If anything is free, then it will start transmitting to that. Here in this case, A and C, B all are free, so S can transmit to any nodes of A, B and C. So the nodes within the range, so this is the range within the S nodes. So the nodes within the S range is A, B and C. So only within that range it can sense. That is a receiver based on the transmission, based on the sensing node. It will send the packet. If it is free, it will send the packet up. And then these are the protocols which is used, and which is able to find the best cognitive mission to mission. So there are n number of ways, and then this is for bring forth this cognitive mission will bring forth the IoT technologies. So successful cognitive radio technologies requires energy efficient, reliable and internet enabled protocol stack throughout the TCP layer. Thank you, sir. So likewise we have compared n number of things. So we have made literature survey, and then we have made a number of literature survey. So first is there are different protocols which are based in the cognitive mission to mission. PRAM based cognitive, CRB, this is packet. This gives 60% throughput per scalability. So we are going for CRB, and is high reliability, less transmission. But this is token based MAC protocol, which increases the throughput and significant performance will be degraded. And then this protocol stance is guaranteeing that reachability, scalability and reliability, but there is an issue over the link layer. So likewise we have surveyed n number of papers, and I have concluded this with a limited number of words, and so that we can able to understand. So cognitive mission to mission technologies are the upcoming technologies which is going to rule over the world, because n number of devices may be connected with each other. We can connect wherever we are, and we can use the internet as is possible. Thank you, sir.